Okay, welcome to our first grade 12 video from the Kanisagasi Enterprise. Now, before we begin, there's a few things that I just have to mention. And the first thing is that in this video, the first part of this video, as you can see from the intro, it says part 1. This first part of the video will be focusing mostly on just the theory, and we will look at the questions, but answering the questions will not be done in this part of the video. So what will be happening in this video, we will see some questions from past paper, and specifically the past paper that we're looking at is the November 2015 past paper. And so what we will do is we will look at the questions and just discuss it and the approaches in which we could possibly answer the questions. But before that, we will look at the theory and ensure that we understand the theory and also know what the theory means. Okay, so the first part that we have to do. Okay, now the topic that we're looking at today is sequences and series. And with sequences and series, there are three types of sequences and series. The first one is what we know as the quadratic sequence. And the quadratic sequence is something that we were introduced to in grade 11. And then we have what we call the arithmetic sequence, and then we have the geometric sequence. All three of them are quite important, but the geometric and arithmetic sequence are the more general and more widely used sequences. Now, the first one that we have that we're going to look at is the quadratic patterns, right? And the quadratic patterns' definition is that the second differences are equal where the first term form an arithmetic sequence. So, what is it trying to tell us here? It is trying to tell us that we would have a sequence, and in that sequence, for instance, if we had a sequence of 4, 9, 16, we would have the first differences, or the first difference, or the first line of all these differences that you get from subtracting the second term to the first term. They will result in a arithmetic sequence, right? But once it's still arithmetic, it's not really telling you much about the sequence itself and how to get it, right? So what you have to do is to get the second difference. And once the second difference is equals to each other, right? Once the second difference is equals to each other, you see, are equal, then you know that you are working with a quadratic pattern. And the quadratic pattern, when you look at the general formula that you use here, it is the t of n is equals to an n squared plus bn plus c, right? And then to calculate the values of a, b, and c, which is always going to be the general question that will be asked, is you first need to say 2a is equals to the second difference, and 3a plus b is equals to the first difference, and ab plus c is equals to the first term. So the first term. Now, notice something here. They just said here, i.e. term 1 minus term 2. And that is true because when you look at generally a tnth of this, if you had to say tn, use the tnth formula and put 1, 2, 3, and etc., and you get a generalized sequence, and then you simplify it by obviously taking the first term, the second term minus the first term, and etc. So this is not correct here. It's the second term minus the first term, sorry. So the first term, the second term minus the first term to give you the first difference. And once you get your first difference, you do that same thing, and you would find that in actual fact, your second difference for all the generalized tnth of the quadratic formula would be 2a, and the first difference will be 3a plus b, and this 2 will be a plus b plus c as the first term, right? Now, let's look at, and you can see where this a plus b plus c comes from, right? If your tn was 1, then what you'll be left with is a plus b plus c, you see. And your second term, if you said 2, then it would be 4a plus 2b plus c, and then when you subtract, when you take 4a plus 2b and you subtract it by ab, you can see that there's 1a, there would be 4 there, it would be 3, and also c would cancel each other out, and you know this was 2b, but then when you subtract by the first term, then it's b, and then we get plus b. So you see, that's where our first difference comes from. Okay, and then we look at generally what we talk about, the arithmetic patterns, and also the arithmetic patterns, right? Now these ones are quite important because they come up a lot in mathematics in general, and they are just standard. And I mean, there are other terms that we call arithmetic patterns. For instance, we can call it a linear pattern, and so on and so forth, right? Now, a definition for it is that all first differences are equal. You always add or subtract a constant difference. So what does this mean? This means that in actual fact, what we have is that if we would have a interesting pattern, yes, I know this pattern will not give us equal differences, but just bear with me. But when you subtract both of them, they're supposed to give you an equal first difference. And if they don't give you an equal first difference, then you know this is not an arithmetic pattern. And now you'd have to look for which other type of pattern there is. But remember, these are not just the type of patterns that you usually find. There are what we could call irregular patterns, where in actual fact, you, like for instance, the Fibonacci sequence. The Fibonacci sequence is where we find that the numbers themselves, they don't actually have an arithmetic or a geometric pattern or a quadratic pattern, but it's more of an intuitive progression or recurrence of the pattern itself and addition. Okay, and so the definition for this one is that all first differences are equal, right? Meaning that in actual fact, when we say the tnth, or the second term minus the first term, we can say that it is equals to the third term subtracted by the second term. So, and it goes on, you can also go and say the fourth term minus the third term is equals to this term here, and so on and so forth, right? So that is the first difference, right? And that's what it means. But the first difference in terms of its general term or general formula is that it's the deed where it says the difference of the two terms that you have taken, the consecutive terms that you have taken, will give you the common difference, right? And so this is the general formula for Tn. And Tn is equals to A, which is the first term. A represents the first term of the sequence. N minus B, that's the term number. And D is the common difference. Now, I know that some people do not use this formula. They try to use the linearized formula version of it. But it is the same per se. But yeah, this one is better because it's more generalized and it's more, yeah. Because with this formula here, you would need at least 2 points. But here, you'll only need maybe 2 things from the thing. So just, yeah, whichever one you'd like to use, you can try whichever, but generally I would prefer that you try and master using this formula as your Tn. Okay, and now then we also have sums of the terms. Now, before we start talking about sums or this particular formula here, when we talk about sums, we are not talking about a sequence anymore, right? Because a sequence is just a list of numbers, right? For instance, this list of numbers here, it's just a list of numbers. But when we talk about a series, right? When we talk about a series, then we start talking about something quite different. We are talking about actually these numbers being added together to a certain finite value or infinite value or infinite number, right? Now, that is a sequence and series. So if you do not know what the difference of a sequence is and a series is, now you know. is that the sequence is where we just have a list of numbers that we've just placed next to each other. But when we talk about an actual series, then we actually have numbers that are being added to each other to an infinitely many number of times, or we are just adding it to a finite number, right? A finite number. So now we look at the sum of n terms, and so the sum of n terms of an arithmetic pattern is that obviously Sn is equal to n of 2n, n of 2, and then it's 2a n minus b, or we can use the second one. Now look here. Now the first one and the second one, the differences are quite interesting. Now in the first one, we are actually just using what we already have, everything that we already have. And what we already have is that if you can find the common difference, then you can use the first one. But imagine if you are given a problem where you cannot use the common difference. And if you cannot use the common difference, but you know what the final term or the last term of that particular series is, then what you can do is you can take the first term and add it with the second term, and then you just multiply it by n over 2 to give you the arithmetic series sum, right? And that is the difference between these two particular formulas, right? So just take note of that and try and understand it as best as possible. Now we move on to the next part, and as I said, this video is mostly about the theoretical part of this series and sequences, but then we will also just look at quickly at the end some questions, right? Now the last part, we talk about geometric patterns. And geometric patterns, the definition: there exists a constant ratio, right? You multiply by the, so the definition of a geometric patterns is that there exists a constant ratio. And what do they mean by this constant ratio? They are talking about consecutive terms. When you take the third term divided by the second term, you will always find that the second term divided by the first term will be equals to the third term divided by the second term. And this is what we see over here, right? So that's what they mean by a constant ratio. Now this constant ratio in the general term or general formula form is actually r is equals to t of 2 all over t1. And this gives us the general term, or the general formula for an arithmetic pattern or the arithmetic sequence, right? And then we have the sum of n terms, and the sum of n terms, you have two of them, but remember now with the two of them, it does not actually matter which one you use, right? And why is that? It's because in actual fact your r, the way they put it, if it's in front or behind, will not really affect the number. But generally this one you would use for r that are greater than 1, and this one for r's that are in between 1, right? So maybe a better way of looking at this is that -1 of r is 1, and this one where we are talking about something that is greater than 1. Okay, so those are the two methods that you could possibly use, but generally you would always know which one to use. Okay, so and then you look at the sum to infinity, and then we have the sum to infinity. Now look at this. This is only appearing for geometric patterns, not arithmetic patterns, not quadratic patterns, but only geometric patterns, right? So you can only use the sum to infinity for geometric patterns. Okay, and then we have the first question. So since I would like to move on to the next video, I will just allow you to just look at it, and then I'll start a new video, and then we will obviously discuss it, and then we'll start doing it from there. Okay, I thank you, and I'll see you in the next video.